Hi, welcome to another 4AC video. In this video, we want to look at this question. A 200 volt 50 Hz AC source here supplies the loads shown in figure 1. So in this figure, there are three loads: load A, load B in series, and then we have a load C, which is in parallel to load A and B. Now, what are we required to do? We are required, number one, is to calculate the real power, the reactive power for load A, B, and C. Next, we want to calculate the overall real power, the overall reactive power, as well as the complex or virtual power, and also the overall power factor. And C wants us to draw a power triangle and indicate all the values on it. And finally, we are required to calculate the values of I1 and I2. Now, this question has some theory that we use from topic 4 of our lecture notes. Let's see how we answer this question. Well, the first thing to do is for me to answer this question. The first thing for me to do is to draw a very rough table so that I can address what we want to calculate. All right, let's maybe we shall identify this as something like that. And this is the power factor, and I want the real power. P, the reactive power, Q, and finally I have the complex or virtual power, S. So we shall look at each load. For example, let's look at load A. Now we are given load A to have a power factor of 0.9. In other words, cosine theta is 0.9. So the angle between the loads is cosine inverse 0.9. That gives me 25.84 degrees. So therefore the sine of this angle will just be 0.4358. Now with this set of information, I can then determine the real power. So PA is given by VI, which is the virtual power, multiplied by cosine theta. So we are given that the virtual power for this load is 1000 VA from the question. Therefore, the real power is 1000 multiplied by cosine theta, which is 0.9. So that's 900 watts. Okay. And reactive power, QA, is just VI sine theta. That's equals to 1000 multiplied by 0.4358. That gives me 435.8 VAR. Right? The units we give it is VAR, or to represent the reactive power. Okay, and the virtual power is 1000. Let's look at load B now. Now load B, we have the power factor. Cosine theta is 0.6. Okay, 0.6. Which means that theta is cosine inverse 0.6. That gives me an angle of 53.13 degrees. Therefore, the sine of it, sine theta, is equals to 0.8. So with this information, I am now ready to determine PB, the real power of load B. The real power of load B is given to me as 600 watts in the question. So to calculate QB, I make use of the relationship power triangle. Power triangle can be drawn this way. PB, QB, and this is the virtual power B. The angle is 53.13 degrees, which means that if I use Pythagoras theorem or I use tangent of the angle, is just QB over PB. So I can then now calculate QB, or the reactive power of load B, as PB multiplied by the tangent of the angle. So that gives me 600 tangent 53.13 degrees. That gives me 800 VAR. Okay, and if I want to find the complex power, or SB, I can make use of again this triangle. It's just the square root of PB square plus QB square. That gives me about 1000 VA. Okay. And finally, load C. Now load C, instead of the power and or the complex power given, I'm just given the impedance ZC, which is 400 and an angle of minus 90 degrees ohm. So if I want to find the real power C of load C, I can look at the rectangular version of this, which means that R is 0. That means the real power PC is 0 watt. Whereas QC can be determined using V square upon X. Now this minus, so it's C. Yeah? So I would have the voltage 200 volts square upon 400, which means QC is 100. Because QC is a capacitive, right? So I have to put in 100 VAR. Alright, so my first part of this answer, the real power for PA is 900 watt, QA reactive power 435.8, PB, the real power of load B, is given as 600 watts. Therefore, QB is 800 VAR. PC is 0 because basically this is a capacitor, so there is no resistance. Therefore, the real power is 0. Whereas QC is minus 100 VA. So that's for part A. Now part B wants me to determine the total values of the real power and so on. So part B can be written as real power P total is PA plus PB plus PC. That's 900 watts plus 600 watts plus 0 watts. So it's 1500 watts. That's the total real power. The total reactive power is QA plus QB plus QC. So QA is 435.8 VAR plus 800 VAR minus 100 VAR. So that gives me a total of 1135.8 VAR. Now then the overall apparent power can be given as the square root of PT square plus QT square. That is 1500 square plus 1135.8 square, whole thing square. So that will give me a virtual or complex power of 1881.51 VA. Now, if you recall, the power factor, overall power factor, is the real power, total real power, divided by total apparent power. So total real power is 1500 divided by 1881.5 VA. That gives me a power factor of 0.797 lagging power factor, because the voltage leads the current since this is positive. So part C is to draw the power triangle. The power triangle PT equals to 1500 watt, QT is 1135.8 VAR. Therefore, the virtual or complex power ST is 1881.5, and this is the angle determined by this factor here, right? So the angle is cosine inverse of 0.797. That works out to be angle works out to be 37.133 degrees. Another way to find this angle is theta tangent inverse of QT over PT. Gives us the same answer. So this is the power triangle. Right, with the right angle, QT, PT, and ST. Okay, and the last part of this question is it wants us to calculate the current I1 and current I2. Now I1 and I2, in order to calculate I1, I need to use the formula I1 conjugate is the total apparent power of A and B divided by the complex number of the voltage. Similarly for I2, the conjugate of this is SC over V. Alright, now since the impedance is given, another way to calculate I2 is actually V over ZC. So there are two approaches. Now the first thing we need to do is to determine what is this apparent power A and B. Now basically apparent power A and B, I need to do is to find the real power of A and B first, which is just PA plus PB. That gives me, from the earlier calculation, that gives me 1500 watt. And QA and B is QA plus QB. QA plus QB basically is 435.8 plus 800. That is 1235.8 VAR. Now, again, I can then draw a rough power triangle where this is P, A, and B, and this is Q, A, and B. So the apparent power S, A, and B is here, and we have an angle. So S, A, and B can be determined from the square root of P, A, and B square plus Q, A, and B square. And that gives me square root of 1500 square plus 1235.8 square. That's 1943.5 VA, and the angle can be calculated from angle is tangent inverse theta of QA and B over PA and B. That's 1235, tangent inverse of 1235.8 divided by 1500. That gives me an angle of 39.48 degrees. Okay, so now the current I conjugate. Conjugate, remember, is the mirror image. It's just S, A, and B is 1943.5 with an angle of 39.48 degrees. VA divided by the voltage. Voltage is 200 of angle 0 V. So that will give me 9.718 at an angle of 39.48 degrees ampere. Therefore, I1 is the conjugate of this, means 9.718. Angle instead of positive is negative 39.48 ampere. Okay, so this is I1. And I2 I can just calculate from here. I2 is just 200 angle 0 degrees volt divided by the impedance, which is 400 of angle minus 90 degrees ohms. That gives me 0.5 at an angle of 90 degrees ampere. Okay, so here you are. I have worked out this question, part A, part B, part C, and part D. Well, hope you learned something from this video. Bye.